Kia ora all. My name is Stanley and I conducted my final year project on the productivity and stem breakage impact of fixed felling heads in New Zealand. So just for a bit of background, felling heads are obviously a piece of machinery used to fell trees. There's a range of felling head variations used around the world with different features and different jobs, but one way you can categorize them is whether they're a dangle or a fixed felling head. As you can see on the diagram on the left, that's a dangle felling head, and a dangle felling head is connected to the boom with a freely rotating link, meaning when they fell the tree, they can't control the descent of the tree. But as you can see on the diagram on the right, fixed felling heads have a hydraulic ram attached onto the boom, onto the felling head, and that allows it to control the tree as it falls. There are more fixed felling heads slowly coming into New Zealand, but dangle heads are still by far the most widely implemented. Fixed felling heads are considered to reduce breakage, which can lead to greater value recovery. And also with the very relevant topic of harvest residues, I wanted to find out first if they're as productive as their dangle counterparts, and then also if they do reduce stem breakage. So that pretty much outlined my project objectives. So at 3 operations, I wanted to determine the fixed felling head productivity, identify its impact on stem breakage, and gather owner and operator opinions on the fixed felling heads. For my reasoning for the project and contribution to the industry, I wanted to provide more information on fixed felling head capability, and then potentially identify favourable conditions that suit it more than others, and finally provide data that can be compared with other felling techniques and equipment. Cool. So for my methodology for starting with productivity, I conducted a time study at 3 operations in New Zealand. I measured the cycle time to fell a tree and then also split that cycle time into 2 actions. The first action was walking to and clearing around the tree, and then the second action was felling and placing the tree. That data was then used to analyse the average cycle and action times, productivity, and then with finding out determining utilisation, I found the productivity per productive machine hour. For the stem breakage, I retrieved the sticks processing data from the processing machine on the top of the skid. And from that, I looked at the small end diameter of the last log that was cut of each stem. And that helped give an indication on whether that stem broke during felling or extraction. And then for getting my owner and operator opinions and comments, I conducted almost an in-person survey focusing on questions surrounding the advantages and disadvantages of fixed felling heads in comparison to a dangle felling head, and also stuff like site suitability. Righto, so here are some photos of my 3 sites. Site 1 was in Te Puhui, just out of Napier in the Hawke's Bay. That was a road lining operation on rolling and flat terrain. It was radiata pine stocked at 370 stems a hectare and had a piece size of 1.8. My site 2 was in Te Puhui, in Kohatu, just south of Nelson, and that was a Douglas fir block stocked at 570 stems a hectare and a piece size of 1.1. And then finally, my site 3 was also in Kohatu, just out of Nelson, but it was a radiata pine block stocked at 260 stems a hectare and a piece size of 2. And then with the slope, as you can see, it was a winch-assisted felling operation. On to my productivity results. Just starting with Site 1. Site 1 returned an average cycle time of 40.2 seconds to fell a tree. And then with a utilisation of 82%, it returned a productivity of 73.3 stems per productive machine hour. As highlighted in the orange there, Site 1 had the fastest average felling and placing time and also the fastest utilisation. For Site 2, they returned an average cycle time of 35.2 seconds, which led to a productivity of 81 stems per productive machine hour. So Site 2 had the fastest productivity in terms of stems felled, which was at 81, and it also had the fastest average walk and clearing time, which I believe was quite down due to the stocking of that block and the trees being a lot closer together. Finally, for Site 3, the average cycle time return was 52.2 seconds. So it's the slowest out of the three, and that led to a productivity of 48.9 stems per productive machine hour. Something that I talked about with the operator and highlighted in that orange square as well, Site 3 had a different base machine. It was a Tiger Cat 855. And Tiger Cat 855's the boom reach length is 4 meters, which is quite a bit shorter than the LTEC 316 base machines, which have a boom reach length of 7 meters. And that with the also what the operator mentioned and what I could see is that there was really dense undergrowth of previous rotations of Douglas fir, meaning that I think with the combination of those two really slowed down the average cycle time for that block. Onto my stem breakage results. Here's a histogram of the 3 sites distribution of small end diameters of the last log cut on the stem. Site 2 can be seen in the orange, and that's where we saw the best distribution of small end diameters, and where that pretty much indicated that there was minimal breakage on that at that site. As you can see, that green circle on the left, over 75% of the stems were in those first 4 bars, all under 150 mil, which was really good. At site 3, that's the one in the blue, and as highlighted in the other green circle, still had quite a lot of stems in that higher SED range, which does indicate breakage was still occurring. And then, that was site 2. And then site 3 is a bit of both in the middle, which is in the grey. Finally, for my owner and operator comments, these discussions I had were really interesting because I was able to get a mix of operators and owner operators of the machine. The main advantages that they identified was first that they believed it had faster felling cycle time than dangle heads. A big one was bunching capability and preparing the stems much better for extraction. This was actually heavily echoed by the hauler operators as well, and they all observed significantly less breakage. For the disadvantages, this was mainly seen in the larger piece size sites where the bigger trees were being a lot harder on the machine, which they think would lead to high maintenance costs in the long run. They all noted that shoveling can be done, and they do it with it, but there are quite a lot of limitations around it, and it is quite hard. And then, lastly, fixed felling heads are a higher cost up front, and I mentioned the boom length already. So just as a summary, the starter showed that fixed felling heads were capable at a range of different sites with varying stand characteristics across New Zealand. When I compared my productivity on my time study with other time studies of dangle felling heads at similar piece sizes, the fixed felling head returned really competitive productivity rates. Other advantages that were highlighted was how beneficial the controlled and directional felling capability was, its ability to prepare bunches, and then the breakage reduction that we saw in orange in site 2. I think for further research, looking at stem breakage before the extraction should be done, as this might help show some more consistent results across the stick starter. This has been done in one study before, but I think it would be good to get more information on that. That's all from me. Does anyone have any questions?